Okay, troopers. So we just finished doing epithelial tissue and now we are on to connective tissue. Okay, so connective tissue is designed to connect body parts. Now that's kind of a little bit difficult to understand because you're using the same word connect twice. So let's just think about it a little bit differently. So remember before when we looked at epithelial tissue, it was just a cell sitting on a basement membrane. And the basement membrane wasn't really a membrane at all, it was just extracellular matrix. So connective tissue is just set up a different way. Connective tissue is a cell, but instead of sitting on the extracellular matrix, the cell is surrounded by extracellular matrix. All right? So not on top, but around. Okay. So just to get a bit of an understanding of where connective tissue is found, for example, in the body, if you have a bone that needs to be connected to another bone, there's usually connective tissue in the middle here. If you have a muscle that needs to be connected to a bone, there's usually connective tissue in the middle. If you have skin that needs to be connected to a bone, again, there's usually connective tissue in the middle. Okay? So that's why connective tissue is being described that it connects body parts. Okay? So we'll come across it a lot. Here we go. So there are many, many different kinds of connective tissue, but I think for you guys, you just need to be aware of the fact that connective tissue is made up of cells living in a matrix. Okay? Cells in a matrix. And there's going to be different combinations of those. Okay? Different combinations. Different combinations of cells and matrices are going to give you different types of connective tissue. Let's have a look at example number 1. Okay, bone. Did you know that bone tissue is a type of connective tissue? It's crazy, isn't it? Okay. Now, we are going to look at the skeletal system later on, but we did a little bit about systems in the first week. So we know that bones are there to protect our body, protect our tissues and our organs, and for support. Bone tissue is made up of cells. There's a cell, there's a cell, there's a cell, there's a cell, okay, in a matrix. Here's the matrix. See? The matrix with Keanu Reeves. I can't even say his name. That good-looking guy. Keanu Reeves? Oh, God. Okay, so here are our cells. Here is the matrix. Cells living in a matrix. Let's look at another type of connective tissue. This is called fibrocartilage. Look, where do we have that? In between our vertebrae in our spine. Okay? It's supposed to make sure that our vertebrae don't grind against each other because that would kind of hurt, A, and B, that will damage your bone tissue. You can't have that. So let's have a look at this tissue. It contains cells. The cells in this instance are called chondrocytes. And then the matrix has lots of collagen in it. Okay? A chondrocyte is just a cell that makes cartilage. And collagen is just a type of protein. Happy days. All right, let's look at the difference between a tendon and a ligament. So you guys are aware of this. Both tendons and ligaments are made up of connective tissue because they connect two things. Tendon connects the muscle to a bone. A ligament connects the bone to a bone, but still connective tissue. Let's have a look at tendon. Let's have a look at an example, right? Look at this tendon. Where is it? We're looking at this tendon here. Tendons are made up of a type of connective tissue called dense regular. That's just a type. Tendons, connective tissue, is made up of cells in a matrix. Let's have a look and see what's in the tendon. The cells that live there are called fibroblasts. And what's in the matrix? Collagen. Easy peasy. Here's another couple of tendons. Let's have a look at a ligament. Okay, here is an example of a ligament. Look, anterior cruciate ligament. Look at that. All right, look at that ligament. Holds this bone and this bone together. Right? A ligament is also made up of connective tissue. And that's it. I hope you are enjoying anatomy. I hope you are enjoying BMS 165. It's not as bad as you thought, right?